Hello, good evening and welcome to NARC Live on Wednesday the 17th of March 2021. Coming to you live from Norfolk on the east coast of England with Tammy M0TC.
Hello.
And David G7URP. Good to be with you. We'll tell you what we're laughing about in a moment. But you heard a bit more music than you normally did, didn't you? Last minute panic. Anyway, on tonight's show, the story of transatlantic radio communications with Frank W3LPL. More details of Ofcom's ICNIRP and EMF. And we find out who works from a shack like this. Now, we have had some entries, but if you would like, you didn't get around to sending us an email and you'd like to enter now, you can drop us an email. Put a message. Don't drop us an email. Put a message on Facebook or on BATC now with whose shack you think that was. The clues were in the newsletters and it said, no bottle of Uncle Jack Daniels here. And does the owner of this shack really cut the mustard? I'll leave you with that thought. Get your guesses into us in the next couple of minutes, really. Anyway, first, it's all about ICNIRP and EMF. I'm sure most of you who are watching this and who are licensed, have a license with Ofcom, you'll already had the email and there may be another email last week with updates on it. It's all about a new variation really, or a new addition to our licenses which will come into effect from 18th of May this year. And it concerns basically the amount of radio emissions that come out from our aerials, wherever we are, whether we're at home, whether we're mobile or whatever. And amateurs are going to have to report this and have a report that's available. Now, there isn't any urgency in it. I don't think that was maybe the clearest of things in the Ofcom. As I said, it doesn't actually come into play until the 18th of May, and until then we don't even know exactly what the regulations are going to be, although we have a pretty good idea, and we've a pretty good idea that it's going to happen. And even from the 18th of May, you will have 6 months in which to prepare a report. So there is nothing to really worry about. I've had lots of emails on it, but there is no urgency on it. This is official. Now, if you're a member of the RSGB, today or tomorrow or in the next day or so, you should get your copy of RADCOM. And in the latest RADCOM, there's quite a lot of information on it. I think Tammy's just going to show us that. I've just realised I haven't got my glasses on, which I'm struggling to read.
Yeah, I thought that. Do you know what? I don't think I've got a microphone.
Never mind.
Either, actually.
Okay, well, I'll try and read this, but I might struggle. I normally wear my glasses nowadays for this sort of thing. Anyway, as you can see, you don't need to read every word of this. If you already get RADCOM, you will get this in the next day or so. And you can see that there's some information there that's useful to you, and there has already been a few changes. So my message as it was before is not to panic. Don't worry about it. But next Wednesday on NARC Live here, we've got our two EMC officers, Mike and Tony, and also Steve G0KYA, who is an expert on aerials, to give us advice and give you, club members, and anybody else watching, of course, as well, some advice on what you need to start thinking about maybe now. But once again, please don't worry. It's not urgent, and that you'll have plenty of time to do this and plenty of help as well later on as well. So, okay, thanks. I'll try. If I don't know what I'm saying, you'll know it's because I'm struggling to see with that. It's strange, I've worn my glasses all day here at work. I'll just quickly tell you what was happening. A moment just before we were about to go on air, we were playing the music in, and we suddenly noticed that on one of the streams, I think it was Facebook, we weren't actually broadcasting any audio. So we had to do a quick restart. You know what computer things are like. And that was the rush.
You probably saw that actually. I suspect on Facebook it was a quick on and off.
Or maybe, yeah.
On the picture.
Tammy had to take her mic off very quickly and do all this.
I have my mic back on.
That was the rush, and that's why my glasses are somewhere. I have no idea where. Let me just have a look. Are they in here? Oh, they are in here.
Oh, sorry.
I'll be able to see what I'm doing. I feel almost naked without them. Am I allowed to say that? It's been a funny day, so this is just sort of capped it really. Anyway, that's next Wednesday, NARC Live, all about ICNIRP and about EMF, and we hope to help you with that, and just to have a look out for the RADCOM as well. I did mention it as well last week. As well as that coming up, there's got the RSGB have organised a Tonight at 8 webinar on it on July the 5th, which Tammy and I host for them technically. And also John Rogers M0JV is going to be speaking after the RSGB online AGM this year on April the 24th. So there's going to be lots of information that you're going to get well before and just after it all comes live. Now for next week, just one other thing, if you've got any specific questions that you'd like to ask, you'll be able to ask them on the night, because our EMC officers and Steve will be here live, and you'll be able to see them and ask questions on here. Or if you want to, you can email them to us. I don't know, Tammy, putting you on the spot, I don't know if you can quickly show our email address, although we're going to show it several times this evening. There we are. Yeah, if you could just show that. So, sorry, Tammy. This email address, if you don't normally note this down and you want to get a particular question or a point about ICNR IOP and you'd like to get it to us before, it means that this Sunday when we have a meeting to discuss it, we can actually make sure we've got the answers ready for you. So radio@dcpmicro.com, that will get the question to us. Thanks, Tammy. One other thing I will mention as well, it's always a good time to remember, and a very good friend of mine didn't realise, but he hadn't validated his license in the last 5 years. 5 years goes really quickly. So it's probably a good time for you to think about just validating your license. What that means is you need to sign into the Ofcom website and just confirm really that all the details are the same. You need to do that once every 5 years, and believe me, those 5 years come around quickly. You can do it any number of times, as long as it's at least once every 5 years. So have a think about doing that. Now on some lighter things. Now, Tom G8XQD sent us this. He says, firstly, a big thank David and Tammy for tonight's meeting show about collections. That was last Wednesday's. Now for collectors of mice and things rodentical, I think. Here is another collection fresh from the YouTube press. Now, this is about CERN. If you don't know what CERN is, it's an organisation that are based in Switzerland, and it stands for the European Council for Nuclear Research. And they look at the fundamental structure of particles and make up everything around us. Anyway, let's have a look at this video, because it's probably not what you were expecting from CERN.
It's really cold out here. I'm about to go put my coat on. But before we go, I want to take you somewhere here at CERN that you don't normally get to see, that maybe isn't talked about very much. So come along with me and I'm going to show you a little hidden gem. Okay, that's better. Let's go. All right, here we are. It's getting late. It's the end of the working day. We're losing the light, but yeah, I want to show you this. So we're here at the CERN data center, but that's not what I'm here to show you. This is what I wanted to show you. It's the CERN retirement home for old computer mice. Some of them like to swing from the trees. These are the free roaming ones. And then we have the ones that are all tucked away because it's cold. This one's been here a while. Okay, I'm gonna go back inside now because it's really cold. Wait, before we go, I forgot to show you the best part. The cat that guards them. Good kitty.
Now, I bet that isn't what you were expecting to see. And when, Tom, thank you ever so much for sending that to us. When we first saw that, we thought, oh, well, that's about mice and things, real mice, not computer mice. And you just wouldn't expect to see that at CERN, would you? Anyway, it shows that they've got a lighter side as well. Now, something else that I did mention last week, and I'll be promoting for several times, we've got a little while yet, but that's the Norfolk Amateur Radio Club AGM this year. So if you're a member of NARC, and it is only really for members to join us on this, we're going to have an annual general meeting online on the 14th of April. Now, if you already sign up for our newsletter every week, then you will have got an email last week with all the sort of details of the sort of things you need to think about now, with minutes and a financial report and things like that. It was sent out last Sunday. We didn't want to just do that night though and not do a NARC Live, because we know lots of non-members like to tune in as well and watch this show. So we're going to do a short version, a mini version of NARC Live just before that on the 14th of April. If you want to sign up for the newsletter, is it possible to show this, Tammy, actually? Yeah. Because I have had a few emails from people who said, I don't get this newsletter. How do I do it? This is actually live, I think, our website at the moment. So if you go to norfolkamateurradio.org, and then if you go to this bit here, click on website registration, and anybody can do this, by the way. You don't have to be a member to do this, but if you want to get our newsletter, this is how you do it. Then you put your name, your email address, your username, which you can appear on if you want to ever sell anything on the forums or whatever, a password, and then at the bottom, the key bits here is click that newsletter box and click the privacy policy and then click sign up. and that will mean that you'll get at least one email from us, sometimes two, every week. We never sell or use the information, give it to anybody else or anything, and we don't spam with lots of emails. The most you might get in a week is 3, but generally it's 2. So if you want to sign up for that, then you're welcome to do so. That's the way you have to do it, though. We can't just send them manually. It's all about privacy and permission and things like that nowadays. Anyway, I must just thank, before we go on to your little people, Tammy, by the way, I must just thank you very much for giving me a bit of a haircut. I don't know if you noticed, but I did need it. You wonder where I'm going with this, aren't you? You're looking worried, Tammy.
Yeah.
You're like something,
but unlike mine was like, I'm putting mine in a ponytail.
I'm glad you said that.
What?
You really didn't. As it's St. Patrick's Day as well, I've got a special surprise for you, Tammy.
Have you?
Yeah, I have. I thought, I did a bit of research on giving other people haircuts, because you gave me a nice haircut. Mine's a little bit easier, isn't it?
Yeah.
I mean, after all, I don't get my hair in my eyes like
No.
you do. So I've got a little kit that I've made up here, and I thought we could share it with everybody what to do.
Right.
Now, here we go. So firstly, to get the dimensions all right round, now I think this is about right.
I wonder why that cupboard was open in the kitchen
I've been
earlier.
sizing you up, and I think that's about right. Okay, and I read something else. Another tip is you must use very sharp scissors. Okay, so that'll be all right. We could do this on tonight's show, depending on what people think.
No,
I don't think.
I don't think so.
But I know what you're worried about. You're worried about PPE. I've got all that. Look, gloves, everything.
No, say you're just like rubbing your microphone.
Oh, am I?
There.
Sorry about that. And the other thing, of course, is that being St. Patrick's Day, because we're going to do this straight after the show, if you'd like us to, I thought I'll treat myself.
I think I need some whiskey if you're going to cut my hair.
With the Guinness inside me. Yes. Anyway, tell us what you think. Do you think that's a good idea? The truth is, we didn't get much news from you this week. Tom was about the only piece we had. And I thought, what can we do? Let's talk about haircuts. All right. Let us know what you think. And I won't have this now. I'll just stick to my orange and mango squash.
Yeah.
Okay. Anyway, Tammy.
Yes.
Sorry about that. Over to you. Surprise us with your little people.
The little people is a bit retro this week. So anybody who's seen the film The Matrix from probably the 90s or the noughties, can't remember now, has seen that. But I thought that was pretty cool. And I don't quite know how they've done it.
It's just what I was going to ask.
It's miniature people, so they don't use Photoshop or anything.
They really don't?
No, I don't believe so.
How the heck did they get those
modeled.
things?
So I'm not sure how those screws are actually stayed there, unless they have used Photoshop for that one, but I don't know. But I thought it was pretty cool as the bullets going past him with the sort of kind of slipstream
It's
type
just
thing.
clever, isn't it? Sometimes less is more, and that is just a lovely picture. Miniature-calendar.com. They do at least one picture every day. That's brilliant, Tammy. Thanks for sharing that with us. It'd be nice when films start again. I was looking forward to seeing James Bond. That's going to be postponed twice, I think, isn't it?
Yeah.
Anyway, what have you been doing? So I said we only got news, I think, from Tom this week, pretty much. So if you'd like to share that with us to stop me giving Tammy an actual haircut on here, I think that would be a good thing. Just drop us a line to this usual address, radio@dcpmicro.com. Anything for the show, we'd be glad, whether it's a video, pictures, whatever. As long as it's something that we can credit the copyright with as well, like that YouTube clip, we're allowed to show things like that. As long as they're on social media, then that's okay to do that. So drop us a line. And also, just like to mention this card, which we always talk about. It's our Norfolk Amateur Radio Club greetings card, which we're very happy to send to anybody who you think will be cheered by a card, whether it's a birthday, a celebration, an anniversary. Maybe they're just not feeling very well or they haven't been well. Then we're very happy to send it. Just drop us an email to that usual address and put the name and address and why you'd like to send it. And we'll add your name to ours and send them a card. And it really does cheer people up. Okay, it's that time. We're still doing it.
It's that
I
time.
can't believe we're in the middle of March and we've still got shacks because you've been so kind. This is
Shack number 50.
Shack number
today.
50. So this is probably show number 52 or something.
Something like that. I think.
So let's have a look then at what we gave you as your challenge from last week. Who works from a shack like this?
Okay.
Now, yeah, I'll start off. The first one we got in very quickly that night was Martin M5MSX. Well done, Martin, on a new call, by the way, and your full license. I think this shack could belong to Kevin M0UJD. I'm quite sure that it's an APRS DigiP to top left, and I can see the Cantronics TNC sneaking in on the right. Wow, that's pretty smart viewing because I can't see that. That's cool though. Okay. Tammy?
Ken M0KJW. Well, Tammy, I'm wondering if it might be your brother, Kevin M0UJD shack. From an angle we don't normally see. I know he has 2 of the Kenwood dual banders indoors, and the bits on the bench could be industrial light fittings. Best wishes to you both. Keep safe.
I've got someone, just looked online as well. Sunny M0SYW on BATC has said, is it Kevin M0UJD?
We've had another guess.
Have we?
I've just seen somewhere. Steve, G3EVA. Is the shack Kevin, Tammy's brother?
That's the numbers are building up. Well, I've got a different one here. John, 2E0TWQ, sent us an email, said, hi, David and Tammy. I think this could be Sunny M0SYW shack this week. And he put in brackets, it looks like an army vehicle headlight or spot on the bench top. Doesn't it, actually?
Hang on, where are we? James, M0ZAH. This is without a doubt, Kevin M0UJD shack.
Very confident.
Yep.
Colin M0GMK also sent an email, said, from the clues and the tidy electrics, I guess this week's shack belongs to Kevin M0UJD. I think we need to put them out of the misery. Let's see.
It is Kevin's shack.
My
bruv.
Your bruv, my brother-in-law and my mate. Yep, look at that. There's a lot of rigs on there. I thought the Uncle Jack Daniels would have been a good enough clue for them. And then the Coleman's cutting the mustard.
Yep.
Anyway, Sonny said I shouldn't have to, if I have to explain it, it's not a good clue. So never mind. All right, so hopefully that entertained you. Let's have a look at a different shack this week. Who works from a shack like this? There's a lot of stuff there, a lot of computer screens, some radios no doubt, and some other things. Do you know who works from a shack like that? You've got just under a week to let us know. There's a radio on its end there on the left, so I guess that's some kind of SDR. Anyway, I'm sure you can work things out yourselves. Who do you think works from a shack like this? We'll be putting that on the newsletter and on the club website in the next couple of days, of course, as always. You've got until next Wednesday at 3 o'clock to let us know who works from a shack like that. Just drop us an email to our usual address. Here it is, radio@dcpmicro.com. Anything for the show and including your shack guess by 3 o'clock next Wednesday, please. Now, just to let you know what's happening next week on the club, on Monday the 22nd of March, Monday Night Net, Steve G3VA, who hosts the net, said a lively net was held the past Monday night when the subject discussed by 10 stations was the favourite drama programmes. This week, coming Monday at 7:30 on GB3MB, you'll be reminiscing about our childhood TV programmes. Please feel free, anybody, to join in if you can get into GB3MB. Everyone welcome, of course. That's Steve G3VA. At 8:30 on Monday, also, we've got the 80-metre CW net. It's not the last Monday, so it's not a straight key yet. That's at 8:30. And next Wednesday here on NARC Live, as I've mentioned earlier, we've got the ICNIRP special. It's an EMF special just to help explain from a club perspective what we think of all the new Ofcom regulations that are going to come in and the sort of thing that you could start thinking about now before all of the regulations are published on the 18th of May. So that's next Wednesday. And don't forget, of course, we'll have all our regulars, your stories, hopefully, your pictures as well. And the Who's Shack, of course. And we've got, this slide is on our website at all times. It's the Norfolk on the Air slide, whether it's a NARC net and lots of other nets. If you'd like us to publish a net that you run on there, we'll put it on there, and it's on the website at all times. The website, of course, is at www.norfolkamateurradio.org. That's it. I think we got through it.
We did.
And we're on air still.
Yep.
Fantastic. I bet you're looking forward to that haircut later.
Yeah.
Anyway, we're now on to our main event. And our guest tonight is Frank Donovan. And we last met him in September. But tonight he's here to share with us the history of transatlantic radio communications. So it's welcome and going live now to Maryland to welcome Frank W3LPL. Hello, Frank.
Hello, David. Nice to be back here on St. Paddy's Day. That you've chosen someone with an appropriate surname for today.
Yes, of course, Donovan. Yes. So have you got any Irish descent?
I Well, my grandfather was born in Ireland.
Oh, well.
I have many cousins in Ireland that I only discovered them about 8 years ago after doing some genealogy research and a good deal of luck.
Good. So, and is it something you celebrate? I know St. Patrick's Day, from what I remember when I used to go to the States a lot for work, is something that's celebrated quite probably stronger actually than in Britain, or at least in England, should I say? Do you celebrate it?
Well, normally it would be celebrated very strongly, but this is an off year again, so hopefully next year things will return to normal. Of
course, yes. I remember all the Irish pubs and things in the American cities that I used to visit a lot. You know, they used to really have a day if I was ever over there. Actually, I used to be over there this sort of time of year as well. That's probably why I saw it. Anyway,
I never had any difficulty finding Guinness in England, though.
No, that is a tip. I mean, you can get it on draft as well quite a lot, but I guess the real place to have it is over in Ireland. But anyway, I guess we're not here really to talk about that. You're going to tell us about the history of transatlantic radio communications tonight. So I'm going to hand over to you now. Just remind everybody at home now that this is live. Frank's there live as well, and we'll be able to take questions. You can either ask questions during his talk or straight afterwards. But now we're really looking forward to hearing about this history. Frank, over to you.
Okay, David, and what would you like me to use as a target for when I should finish the presentation?
Well, I don't mind. I mean, as long as you think it's going to be, you know, something like an hour maybe or something like that, and we've got time for questions, as long as you're okay.
I'm fine, but I'm a few hours earlier than you.
Oh yeah, what time is it over there, by the way? I should say that.
Well, we're on daylight time here, so it's a 4-hour time difference.
Okay, all right. Well, that's not too bad then, I guess. So
no.
Anyway, but as I said, please feel free to ask your questions at home at any time, and we'll read them to Frank at the end. Thanks.
Okay, so off we go. So you'll have to excuse me because this presentation will have a distinctly American orientation. But the Marconi Company was very prominent in England during the time that transatlantic and later transoceanic communications was being developed. America took a pretty substantial role in the development of the technology, but the Marconi Company was way ahead of everyone in terms of turning these technologies into actual functioning commercial capability. And I'll show you a little bit of that, but not a great deal. This is mostly an American perspective. And most of this presentation will deal with the advancement of technology rather than the various radio stations and so on that are famous and interesting to discuss. They were scattered all over England, but it'll be mostly about technology. So let's get started. So I got interested in this. In America, we have what's called Armed Forces Day, and for many years, the military has participated in that with their military stations, and our equivalent of Ofcom, called the Federal Communications Commission, allowed on that one day a year only for American hams to communicate with military stations. Normally that's strictly prohibited except in some sort of an emergency. So that one day a year we can do it, and I've been involved in that activity both as a ham looking to make some of these contacts and also operating at some of the military stations. Well, most of these military stations are no longer on HF. So the process of putting the station you see in the image here back on the air is very much like operating an amateur radio field day, because almost all of these towers you see in this photograph were long ago taken down, and the ones that remain are not allowed for us to use. And we, 3 years ago, celebrated the 100th anniversary of this Naval Radio Station NSS that's located about 40 miles east of my home. So this is just a very brief recap of some of the main events related to Naval Radio Station NSS. And all of this, from a technology point of view, begins with Marconi's transatlantic test, the very famous one in 1901. But also other operational systems that Marconi deployed, commercial systems. right up until World War I, when his business was basically terminated for the duration of the war. And I'll show a photograph and a little bit of the equipment that the Americans installed at a station called NAA, which is very close to the White House in Washington, D.C. The buildings are still there and still used for administrative purposes, but the radio equipment is long since gone. And in 1917, the United States Navy seized all of Marconi's assets in the United States for use during the war, and they were never given back to Marconi after the war was over. He was required to terminate his ownership of all of them. And I'll show a couple of photographs of the station that the U.S. Navy seized from the Marconi Company and used for communications with Europe during World War I. So let's, I won't read through the rest of these. Let's get into the main part of the presentation. So radio can logically be traced back to the work of James Maxwell, a well-known British mathematician and physicist, and he predicted mathematically that electric fields, which were well known at the time, and magnetic fields, which were well known at the time, could also travel through space as an electromagnetic wave, where both electric and magnetic fields are present. And he developed the theory of this, and this is his book shown right here, and you can get reprints of that book. It's very mathematically intense. Unless you're a mathematician, I don't recommend it. But and he was quite happy when he finished the publication of his work that he was done. There was no need to go any further. And that work kind of ended in the 1860s. Until this fellow came along, Heinrich Hertz. And his motivation was to prove the existence of electromagnetic waves that Maxwell had predicted mathematically. And during the course of this work, he was asked about applications for electromagnetic waves, and he very firmly replied that they're of absolutely no use. Hertz's experiment was just that, and his only intent was to prove that Maxwell was right, which he did. And sure enough, when Hertz finished with that proof, he moved on to other things, never to come back to electromagnetic waves. And this is an image of his laboratory. And in this laboratory, you can see his transmitter, his transmitting antenna, his receiving antenna, and his receiver. And the transmitter is here. It's a high voltage generator, nothing special, converted to radio waves by this spark gap right here in the photograph. And then this is a 6-meter dipole that we might use for ham radio communication on the 6-meter ham band. And I don't know why he thought he needed to have these globes on the end of the dipole, but sure enough, he did that. So this is his transmitting station, and his receiving station is this loop right here. And that's the receiving antenna. And the receiver, the actual receiver itself, and I'll show that in the illustration, is over here. The receiver is a spark gap. So what he demonstrated was that these electromagnetic waves existed because when he energized the spark gap on the transmitter side and fed his dipole antenna, sure enough, the metal ring, which we would call a one-element quad, caused a spark at this, and he was quite happy with that, and he was finished and moved on. But thankfully, and then this work kind of languished for a while until Tesla got interested, but from a different perspective. Nikola Tesla was mostly, well, I would say entirely interested in power transmission. And in particular, he had a strong interest in wireless power transmission and put a great deal of effort into that. And he developed something that proved to be quite useful for radio during the 20th century. But as often happens very early in the development of technology, they didn't connect Tesla's invention to its utility for radio. And this is one of his many inventions. This is a high-frequency alternator. It was capable of operating at about 25 kilohertz, but would routinely operate at 10 kilohertz, about 10 kilowatts of output. This was driven by a belt at about 3,000 RPM. And you can see all of the magnetic poles that are constructed in here. And, but this particular device was never applied for radio use, and perhaps one of the reasons was there was no receiver. So he had a way of developing 10 kilowatts of power, but no technology available to receive this signal. So he never went on to become particularly well known as a person associated with radio. But this was an incredible device that could have been used very well. But then this fellow came along, Marconi, and his. And by this time, he was living in England, and most of his, in fact, I would say all of his work, his commercial work was based in England. And this is a photograph of the famous transmitter that was used in the first transatlantic transmission from Cornwall, England, to Newfoundland. And this photograph was modified by somebody years ago, and it's this illustration of a spark gap, but it's very apparent when you look at this photograph that it looks like this was added. But let's ignore that detail. This was a spark gap transmitter, and perhaps the spark gap was out of view in this photograph or something. I don't know why it was altered, but clearly it was. But this is a very dangerous transmitter. I'm sure you had to be very careful when you walked into this room. It was a 10 kilowatt spark gap transmitter, so very much the same kind of simple spark gap that Hertz used. And it operated at roughly 500 kilohertz. And that was mostly determined by the size of the antenna, because the spark gap is a very broadband emitter, but the antenna would have limited the frequency at which it operated. So when we speak about the Marconi first transatlantic transmission, it was at about 500 kilohertz, more or less. And this was the antenna that he used. It was hastily put in place. There was a much, much larger antenna that was intended to be used for this experiment. But just before the transmission was to take place, the entire antenna system fell apart, fell to the ground. So hastily they installed this one with a couple of the remaining 150-foot poles, and this is the antenna that was used. And this is the receiver. This is absolutely incredible to even think that this could be a receiver, but this was the technology they had. So it was discovered at about this time that if just the right kind of metal filings were included in a vacuum tube, as shown here, and if you applied a radio signal to the terminals of this vacuum tube, that the metal filings would cohere to the electrodes. So literally, the process of copying a Morse transmission by radio consisted of jostling this device a bit. They usually used a small rubber mallet and scattered the filings around. And then if a radio signal should be received, the metal filings would cohere to the electrodes. And then once that happened, you had to get your rubber mallet out again and loosen up the filings so that you were ready to receive the next Morse element. So you can imagine the laborious process of trying to copy Morse code with this device and a rubber mallet, and I have no idea how you decide. If the filings have cohered adequately or not. I don't know that much about the technology, except to know that it was incredible that they could get this to work at all. But this is what they started with. And later there were some mechanical devices so that the small rubber mallet could be automatically engaged to loosen up the metal filings for the next Morse element. And this is the antenna they used in Newfoundland. A wire suspended by a kite. And this is a illustration of what that kite might have looked like in 1901. Well, when Marconi claimed his success, and there's a good deal of disagreement as to whether he actually was successful or not, because there were no witnesses. He failed to get anyone to witness the reception of these signals. So he claimed that he received the Morse S character that was being sent from Cornwall, but no one was with him to observe that it actually was received. A mistake that he never repeated in subsequent testing in his career, but he made that mistake here. So you have to trust his word that he actually received it. Well, once he publicized the success of his experiment, Newfoundland was a popular place for transatlantic cables, telegraph cables that ran from Newfoundland under the ocean to Ireland. I think most of them terminated on Ireland at that time. And surely some of them terminated in Cornwall as well. But the commercial interest in Newfoundland said that we're going to sue you if you attempt to carry out these experiments any further. So Marconi quickly gathered his materials and moved on to a different place. So he did no further work in Newfoundland after the successful test in 1901. And where he moved to was Nova Scotia. So it's not that far. It was 300 or 400 miles south, I suppose, of where he started. Found this wonderful location. The building you see in the photograph is now a radio museum open to the public in the summer with limited hours. So if you ever find yourself in Nova Scotia, make sure that you are aware of the opening hours if you want to visit this museum. And this is a fantastic location. It's a small peninsula that juts out into the ocean. So these towers and antennas are surrounded on three sides by ocean water, with nothing between him and Cornwall but ocean. And he continued engineering tests between Cornwall, his station in Cornwall, and this station for several years, but discovered that the antenna was both at Cornwall and in Nova Scotia were too small for reliable communication. So he had to go back again and rethink about how to make a much larger and more effective antenna system and a much higher power transmitter. So they went off and did that, of course. And in the meantime, in America, this engineer and scientists went on to develop much higher power transmitters. And this transmitter that he developed was the first high power CW transmitter. Up until this point, all transmitters were some sort of spark or arc technology, and I'll explain the difference in those in a little bit. And this is the synchronous rotary spark transmitter that Alexanderson used. So this is still spark. This is 1906. And this was the first successful two-way transatlantic radio communication. It was between Plymouth, Massachusetts, very close to where the Pilgrims landed just over 400 years ago, and the southwest coast of Scotland, kind of due west of Glasgow. And this is a photograph of the transmitter. These are huge, huge devices. I don't know what this transmitter weighed, but probably several tons. You can see in the background of this photograph the actual electrodes that were driven by the motor that produced the spark, the synchronous rotary spark. So this was 35 kVA. So this transmitter probably put out in the order of 10 kilowatts or so of power. So that was a major improvement, and this was successful. But weeks after this took place, the antenna in Scotland fell to the ground. Another fascinating thing happened at about this time. Lots of things going on. So Fessenden is often credited as being the inventor of CW communications, CW as opposed to ARC or Spark. And he also he invented the heterodyne receiver, but ran into a major problem. So this is, Fessenden was the engineer who put together this station in Plymouth, Massachusetts, and the west coast of Scotland. And this is the mast that he installed. So they were starting to figure out that in order to successfully communicate across the Atlantic, you needed very big hardware. They were operating at frequencies around 50 kilohertz or so. And an identical 400-foot tower was installed on the west coast of Scotland. And fortunately, they were able to complete this successful two-way communication before the tower in Scotland fell to the ground. So Fessenden patented the heterodyne receiver. It's a very simple receiver, but the reason he was unable to turn this into an actual functioning receiver was that there was no such thing as an oscillator in 1901 when the patent was filed. The Audion vacuum tube, we would call it a triode today, hadn't even been invented until 1906. So this patent didn't go anywhere. So in 1901, they kind of knew about antennas. They knew about simple detectors, but no oscillator. And the oscillator is kind of the key technology in a heterodyne receiver. And so this patent went nowhere for quite some years. So along comes DeForest, and he invented the three electrode Audion, we call it a triode. And it was the first device capable of amplifying an electrical signal. Unfortunately, DeForest invented this thing and didn't really know how to put it to practical use. That would take yet another person to make that major step forward. And this is a photograph of what that Audion, or triode as we would call it, looked like in 1906. It was literally a electric lamp that had been modified. You can see the grid. It kind of looks like a paper clip that's been bent, but that's the grid right there. And the plate is right here, literally a plate. So that was the first triode, but no practical use was put to this for quite some time. So let's go back to Marconi because he's doing his work. And by 1907, he becomes very successful and puts in place the first commercially viable transatlantic communication system. And he did it with truly massive hardware. His wife was of Irish descent, and she was able to get access to a very large tract of land to the west of Galway, Ireland, a place called Clifden, right on the ocean, about as close to North America as you can get in Ireland. And they built this huge station you can see on the left, and I'll show you a map of this station to give you an idea of just how large it is. But the first antenna was 200 feet high, 200 feet wide, and 1,000 feet long. And it was quite successful in the first tests and the first commercial operation starting in 1907. And the companion station in Nova Scotia was moved from that fantastic location, but unfortunately that location was too small, to a much larger location in a place called Glace Bay, Nova Scotia, not far from the original location. And this antenna was 2,200 feet in diameter and 200 feet tall. Well, unfortunately, after about a year of operation, the station in Nova Scotia burned to the ground. And so that was an opportunity to improve the station in Ireland, because the antenna proved to be much too small. Hard to imagine that a 200 foot high by 200 foot wide by 1,000 foot long antenna would be too small, but it was. So it gave an opportunity to build a much bigger antenna, and also to build a duplicate of that huge antenna when they rebuilt the Glace base station in Nova Scotia. So sure enough, by about 1910, they were back in operation with much bigger hardware. And this is a look at the hardware that they were using. This is Marconi's 300 kilowatt rotary spark transmitter. Notice he's still using spark. He has not adopted the new CW technologies, and never did before World War I. And I don't know how much this weighs, but probably in the order of 5 to 10 tons. And typical for the technology used in the VLF range, all of the hardware is truly massive. The rotary spark is enclosed here, so you can't see the electrodes. And they installed one of these 20 kilowatt rotary spark transmitters in both Clifden and in Glace Bay, Nova Scotia. And this is a look at the condenser house that was installed in both of these sites. This is a 1.8 microfarad condenser. Today we would call it a capacitor.
Goodness.
And it provided 18 kilovolts to the spark transmitters. And how big was this condenser? It was 350 feet long by 75 feet wide. Consisted of 1,820 metal plates, each plate 30 by 12 feet. Sometimes this era of radio is referred to as Jurassic radio. And you can see why, because everything is truly massive. But it was what they knew how to do. They couldn't go to the local electronic distributor and buy what they needed. They had to invent everything, and what they knew how to do was this massive stuff. And this is a map of the Clifden station west of Galway, Ireland. And this is the second generation antenna after the 1909 fire in Canada. And this antenna was 2,500 feet long and 800 feet wide and 400 feet high. And this provided a very viable and quite reliable transatlantic radio communications capability. This site can still be visited. It's very, very little left of what's here, but there's a trail that's been built through this site, and some plaques and so on that kind of illustrate what the remaining artifacts mean and how they relate to everything that's shown here. But this station needed to be completely self-sufficient. There was no source of electrical power here, so Marconi had to build an electrical generation station, and there was no source of fuel. But in Ireland, everyone knows there's plenty of peat, and one of the reasons this site was chosen was because there was an ample supply of peat. So Marconi not only built the radio station and the electrical power generation station, but he also built the peat mine and the railroad that transported peat from the peat mine over to the electrical power generation station. So he really had to do everything here. So America is still involved in this stuff, and Edwin Armstrong, during World War I, developed the first radio receiver using electron tubes. And he used the Audion. And later, a few years later, he would go on to take Fessenden's heterodyne patent, and he developed only a very slightly different version of that receiver called the super heterodyne. But the advantage that Armstrong had at this point was that he could now use the Audion vacuum tube to also create an oscillator, which Fessenden could not do in 1901. And this is Armstrong's patent for the regenerative receiver. This is obviously before World War I, so this is 1913. So the vacuum tube that's shown here, you call it a valve, is the Audion triode. And I won't go through all the details of the schematic for anyone who's interested. I'll make the slides available to David if he wants to share them, and you can look at this in a little more detail. But this regenerative receiver instantly made all of the crude detector schemes instantly obsolete. And this really led to the explosive growth of radio after 1913. Surprisingly, 2 years later, a patent was awarded to the American Telephone and Telegraph Company for a single sideband transmitter. And most people are very surprised to see that this technology was patented before World War I, but it was. And it was just kind of a progenitor of what was to come, because single sideband transmitters did not come into widespread use until the period after World War II. There was a little bit of use, some very important use, but it was limited. But 1915 is a surprisingly early date, but that's when it happened. In the United States Navy was, like many navies of the world, very quickly realized that without the capability of radio, any competing navy that did have that technology would be a major threat. So the U.S. Navy took this very seriously, and this Admiral Hooper is generally credited as being the father of U.S. naval radio. This is the first major U.S. naval radio station. It was built in Arlington, Virginia. Those of you who've been to America would recognize that there's a well-known American military cemetery there, where, among other things, President Kennedy is buried there. And just a short distance from Arlington Cemetery, this building is still there, and it housed the U.S. Navy's first major radio station, NAA. It was built on only 13 acres of land. Apparently, the Navy had not been paying attention to what Marconi was doing, because you may recall that Marconi started with smaller antennas and went to bigger antennas, and then bigger, and then ginormous antennas. But the Navy kind of went through the same learning experience, starting with smaller antennas and realizing they weren't big enough, and they went through all that learning again, 10 years after Marconi had already learned that lesson. So these are the three big towers that were installed on that 13 acres of land. And this antenna proved to be too small for transatlantic communication. It was fine for communication around the East Coast of the United States, but very unreliable beyond that range. And this is a look at the technology that was used. It was also spark. And in this case, the electrodes are visible in this device right here. You can see all those spark electrodes. And this was about 100 kilowatts, so the power was higher, but the antenna is much too small. Well, World War I came along, and by this time, Marconi was well along his way of taking the successful early commercial success between Ireland and Nova Scotia and developing that into a worldwide capability. And among the stations he built was this station in New Jersey, a place called New Brunswick. But once America got into World War I, the only way that America had available to communicate with its troops in Europe was via submarine telegraph cables. And they were well aware that that was a very vulnerable way to communicate. And just to emphasize how important, how real that threat was, on the very first day that Britain entered World War I, Britain cut all of Germany's submarine telegraph cables. So if Britain could do that to Germany, then certainly Germany could do that to America. And there was a very serious concern about that, and that put a huge emphasis on developing U.S. Navy-owned transatlantic communication. Well, there's no better way to do that than to seize an existing capability, and that's what they did. They seized Marconi's transatlantic transmitter station here in New Jersey. But they knew from experience that the spark technology was not sufficient. So by then, the technology I showed you early on from 1901 was further developed by Alexanderson. He worked for General Electric, and he built these huge transmitters. They weighed 100 tons. So this transmitter is 43 feet long, 11 feet wide, 7.5 feet in diameter, and it's a CW alternator. And the U.S. Navy removed all of Marconi's equipment from this transmitter station and replaced it with these 200 kilowatt alternators. And it was a very viable capability. Worked very well. And this is the antenna that Marconi had installed in New Jersey, and the Navy continued to use it. It was 5,000 feet long, 400 feet high, and 600 feet wide. Well, the Navy had a big problem, and that is, while they could be heard in Europe quite reliably, the receiving capabilities that they had in America to receive the signals from Europe did not work well at all. And this young man was not yet in the U.S. Navy. He was an amateur radio operator. His call sign was 1AJ. His family owned quite a bit of land right on the Atlantic coastline in Maine, not very far from Nova Scotia. And this ham was listening to the communications of the U.S. Navy between New Jersey and Europe. And he realized that he could copy the signals coming back from Europe very, very well, but he could hear the request for repeats from the transmitter in New Jersey over and over again. And he said, you know, this is a big problem, and I'm sure that I can solve it because I'm doing so much better. So we contacted the U.S. Navy, and the Navy came up to look at his ham station in Maine. And sure enough, the Navy realized that that this ham could very reliably copy these signals. Well, his family owned the land where his ham station was located, right on the ocean front. And Fabry said, I'll be happy to give you this radio station, but what I would like from the Navy is simply that you allow me to be the commander of this radio receiving station, and I'd like you to commission me as a lieutenant in the Navy. And that caused a big problem for the Navy. That was a totally unconventional way in which to become a naval officer. And they just couldn't find a way to get to yes. But the situation became desperate enough that they finally figured out a way to get to yes. And Fabry became a lieutenant and became the commanding officer for what became a U.S. naval receiver station that replaced his ham radio receiving station. And this is a photograph of what it looked like towards the end of World War I. And the only thing I'll focus here on is the receiving antenna. It's a loop antenna, multiple wires. One of the supports here, one of the other supports in the background. It's a big radio tower here as well behind. So this previous ham station became the Navy's most important transatlantic receiver station and was very, very successful. Moving on after World War I, the Navy continued, of course, developing this technology. And this fellow, Leo Young, he became W3WV many years later, and also a member of the radio club that I'm a member of now. He was one of the leading engineers in the development of U.S. Navy radio and radar equipment. And this is a look at the receiver that he was involved in developing. The name of the Navy organization at the time was called U.S. Navy Steam Engineering. This was the first mass production standard Navy receiver, and thousands of these were manufactured in the years after World War I. Well, the Navy had good reason to worry about these cables being cut between North America and Britain. And this is a photograph showing a German U-boat, the U-151. And in May 1918, so we still had several months to go in World War I, this ship, this submarine, conducted the first naval attack on American shores since our friends in England did that in 1815. Fortunately, very fortunately, this submarine did not locate the critical cables that connected North America to England. Instead, they happened to discover some cables that connected to Canada and to the Caribbean, and they cut those cables, but they were repaired just 6 weeks later. So this fear proved to be real, but the U.S. got lucky. And this is a look at the headquarters for U.S. Naval Communications in Washington, D.C. They very naively thought this could be used as a receiver site. And in this photograph, you can see some of the radio towers that were here. But there was far too much radio interference from power lines and other things in downtown Washington, D.C., and this proved to be a quite ineffective radio receiving site. So I had showed you before the photographs of the 13-acre site in Arlington, Virginia. So by then, the Navy had a crash program ongoing to build its own capabilities. No one had any idea how long World War I would go on. So they built this station, NSS, in Annapolis, Maryland, about 50 miles from my home. And they still haven't learned this lesson about building truly gigantic antennas. Now, these would seem to be gigantic enough, but they were nowhere near big enough. 800 feet by 800 feet. You might recall that back in, well, it would have been 10 years before that Marconi had figured out the antennas needed to be 5,000 feet long. It would take a while for the Navy to learn that lesson. So this was the first antenna that was built at NSS in 1918. So the technology that was used by the Navy was something called ARC, as opposed to Spark, which was the earlier technology. And this was developed by this engineer named Poulsen from Denmark. And this is a photograph of the ARC transmitters that were installed at NSS in Annapolis, Maryland. I don't know what this weighed, but it was certainly many, many tons. And to give you an idea of the size of these transmitters, the operator is right here in the middle of the photograph sitting at a desk. I can only imagine how much noise there was in this room when these transmitters were operating. And the ARC technology is an electric arc and a hydrogen gas. And it's and these very large objects you see here in the photographs are magnets, massive electromagnets that were used as a part of that electric arc transmitter. You can learn a lot more about the details of this technology if you're interested by going on Google and just searching for POULSEN ARC, and you'll find out lots of information about this technology. So during World War I, Armstrong invented the superheterodyne, and this is his patent. It was filed in 1919. And superheterodyne receivers very soon obsoleted all of the prior technology, including regenerative receivers. Regenerative receivers continued to be used, but the superhet was a much better receiver technology. So looking at, again, from a US Navy point of view, this was the next generation of regenerative receivers. And there were thousands of these built during the 1920s. Still, well, they were designed by US Navy Steam Engineering and built by American companies to the government design. So along come radio amateurs after the end of World War I. It took some time, several years, for hams to get back on the air. And in the United States, by about 1921, hams were communicating irregularly, but nonetheless some communication all the way from the East Coast to the West Coast of the US. So that's almost the same distance as transatlantic distances. So they knew this could be done. But at the time, amateurs in Europe generally didn't have enough power or large enough antennas to communicate. So they decided, the American Radio Relay League decided to sponsor this transatlantic test. And this would be a one-way test with amateurs in America using their transmitters, and then amateurs in Europe attempting to receive them. And to be sure that that this test wouldn't be a failure, there had been some failures in the year before. This American operator was chosen to go to England, and Marconi, or the Americans also learned from Marconi's problems that they needed to have witnesses. So the Marconi company was very, very interested in this technology. It had the promise, if it was successful, to lead to radio stations that were no longer requiring antennas that were 5,000 feet long and 600 feet high. So this Marconi company inspector joined the ARRL team and witnessed all of the testing that took, all of the transatlantic communication that took place, and also facilitated the use of Marconi's commercial transatlantic communications to communicate back and forth between this receiving site in North America each night, so the operators could tell what was happening. And this is the receiver that was used by, his name was Paul Godley. It was a 9-tube receiver, and at the time, the technologies were such that most receivers were built with the tuner in a separate box from the receiver, and that's what you see here, the tuned circuits in that wooden box on the left side and the 9 tubes on the right. So so if you recall, the objective here was one-way transmission with the transmitters in America, and Paul Godley's friends at the Radio Corporation of America were determined that Paul was going to succeed in his expedition to the coast of Scotland. So while Paul Godley was on the ship going to England, this group of radio amateurs joined together to build a radio station near the Atlantic Ocean in Connecticut using this newly marketed RCA tube called the UV204. And they built, for the time, quite a sophisticated transmitter. And this is a photograph of the transmitter that they built in a temporary building. It used 4 of these 250-watt vacuum tubes. And this was by far the most effective station in the 1921 transatlantic test. It was heard multiple times by the Godley team in Scotland. So this was 1 kilowatt ERP at about 1500 kilohertz, so fairly close to the 160 meter handband today, call sign 1 BCG. So let's move on to what's happening with the Navy. So the four towers in the middle of the photograph are the original 4 towers that the Navy built. And of course, they very quickly discovered that this original antenna was much too small. So they added 2 more towers. So it made the entire antenna system 800 by 2,500 feet tall. I guess they hadn't yet read Marconi's stories about that being too small. But this is what they built on this site in Annapolis, Maryland. And they were able to develop 50 kilowatts ERP at about 20 kilohertz. So this was 1922. So Leo Young, W3WV after World War II, was moving on with his work, and he designed and built this crystal-controlled 10 kilowatt CW transmitter. This would be quite an effective transmitter today. And they built a very similar transmitter to this for the U.S. Army, but it was installed at NSS Annapolis in 1925. A very successful capability. And they discovered, just like some of the commercial companies at this time, that 10 kilowatts at HF was an extremely reliable way to communicate over long distances at HF. We're no longer at these very low VLF frequencies. And this is a look at one of the very early receivers that was built. Thousands of these were built. And Leo Young, W3WV, was the lead design engineer of this receiver. And if you look at the tag here, you can see that the frequency range of this receiver went all the way up to 17.2 megahertz. And there it is expanded so you can read it more clearly. This receiver was recovered from the wreckage of the USS Shenandoah, a very tragic accident. This receiver had been installed on the Shenandoah, and this receiver was recovered from the wreckage shortly after 1924. So technology was starting to move very rapidly, and the rhombic antenna was developed in 1931, and this became the most widely used transmitting antenna for military and commercial transatlantic communication, all the way from the 1930s until communication satellites started to obsolete HF radio in the 1970s. And this is a look at transmitters of that era. This 300 kilowatt transmitter replaced one of those gigantic electromechanical transmitters in 1932. These transmitters are still huge. I don't know the dimensions of this transmitter, but I suspect it was about 25 feet long and probably about 8 feet tall and weighed tons to produce 10 kilowatts. And this is a look at a 50 kilowatt transmitter for HF. And this transmitter weighed 8 tons, was 20 feet wide, 8 feet tall. And many of these transmitters were installed at U.S. Navy stations around the world. This is a look at what receivers looked like during that period. So this is 1932. This is a photograph of the U.S. Navy's first receiver that was powered off of AC mains. This was a super heterodyne receiver. Not exactly a portable receiver. It weighed 450 pounds. And this is a look in the main Navy building in Washington. So they still had receiving capabilities there. And you can see a row of these receivers. I have no idea how many were in the room, but you can see it. There are quite a few of them along here. Those tables had to be built with fairly strong to hold 450-pound receivers. So an interesting thing happened. You may recall the story about Lieutenant Fabry. Well, his naval radio station after World War I deteriorated. It was still in use, but it had deteriorated in terms of its physical appearance quite a bit. And a wealthy family, the Roosevelt family, owned quite a bit of land in that area, and they wanted to develop a park. And it became a national park, ultimately, Acadia National Park in Maine. But there was a problem, and that is this rundown old U.S. Naval Receiving Station was right in the prime area on the ocean front that they wanted to be one of the dramatic scenic areas in the park they were developing. So the Roosevelt family offered to the U.S. Navy that they would be willing to build another naval receiving station about 20 miles away if the Navy would only be willing to tear down this old station where the Roosevelt family wanted to build this park. And the Navy had a very difficult time getting to say yes to the Roosevelts. But ultimately, the Roosevelts prevailed, and they built this U.S. Naval Receiving Station about 20 miles to the north of Acadia National Park. And these buildings are still there. You can see this doesn't look very much like a government kind of a building that the Navy might build. If the Navy had built this, it probably would have been wooden at that time. Today it would have been built concrete, but would have looked nothing like this. So going back to Annapolis, the Navy's starting to learn the lessons of Marconi from around 1907. And they finally built a large antenna system just before World War II. And it was 600 feet tall, 800 feet wide, and 5,000 feet long. Similar to, but a little bit taller than the one that Marconi built in 1910. And now the U.S. Navy had some real capability. And the transmitters that they used by this time were 500 kilowatt transmitters for both CW and fax. This is a look at what receiving stations looked like in the period before World War II. A typical high-performance receiving station would be about 1 square mile, and they were full of rhombic antennas covering many different directions. You can see the rhombic antennas in this diagram. There are dozens of them pointed in a variety of directions. A small operations building in the middle of the site, but surrounded by a square mile of antennas. There were many, many of these in England and America and all over the world. I worked at one of these stations in England at a place called Harrogate in West Yorkshire. And CW had its limits, and by the time World War II came along, teletype became widely used in the U.S. Navy, and this is a photograph of one of the most widely used teletype units, the Model 15, and 200,000 of these teletype units were built. And this is a look at the receive station for NSS. They had moved the receive station away from Washington, D.C. in 1939, built a dedicated receiving station in a fairly rural area, and this is what it looked like at that time. And if you notice, these 450-pound receivers, they're still in use in 1939, these gigantic receivers. This is the next generation of receiver technology during the World War II period. The Navy RBA, which was used on VLF, this was a mere 80 pounds. And the RBB and RBC HF receivers, also a mere 80 pounds. Another member of the Potomac Valley Radio Club was one of the design engineers for this receiver. So during that period, you may recall that a hotline was installed between London and Washington, D.C. It was a voice hotline, fully encrypted. The encryption technology is fascinating to read about. I won't get into it here, but anyone who's interested in it would enjoy learning about that. But we'll look at the receiver technology. It was 3 diversity receivers. Each of them consumed a 7-foot tall rack. And just look at all of the controls involved in tuning just one of these 3 receivers. First RF stage, antenna coupling, second RF stage, third RF stage, IF mixer, band switch over here, oscillator frequency, manual gain control. And you had 3 of these receivers to worry about. So QSYing from one frequency to another was a big deal. This is what they had available. This diversity receiver weighed 1,700 pounds. So this was the system that was used for Roosevelt and Churchill to communicate regularly by secure voice. And this is what the transmitters looked like at that time. This was a single sideband transmitter in 1943. And this is a 2 kilowatts single sideband transmitter. And later in 1943, the company called Preston Wireless, which built transmitters for press communications between newspapers. So they were in the transmitter construction business, so the Navy entered contracts with them, and they built this 15 kilowatt transmitter capable of 400 words per minute using the Teltec equipment. This is a look at the kind of transmitter that was used on the hotline between Churchill and Roosevelt during World War II. So a 40 kilowatt transmitter. And this is a look at that transmitter at one of the operational sites. So this technology coming to an end. And this well-known article in Wireless World magazine in October 1945 was written by a gentleman named Arthur Clarke. And he forecasted in this article extraterrestrial relays using satellites. And of course, this would be the technology that just 30 years later would obsolete everything that I've showed you. So a couple more transmitters to look at here. These are next generation 40 kilowatt transmitters from 1948. And this is a low frequency transmitter from 1952 that's still pretty gigantic. I don't know how long this transmitter is, but it looks like it's about 40 feet. Technology came along to pack more and more telegraph channels into single sideband transmissions, and this is a look at some of that technology from the early 50s. In order to communicate, especially with ships, you couldn't place very many antennas on a ship, so this technology was developed. It's a transmitting antenna multiplexer developed by NRL that would allow 2 transmitters to share the same antenna. And quite a bit of new HF antenna technology came along in the 1950s. And this is a look at one of the early log periodic arrays. This was, the log periodic array was patented in 1957, and countless thousands of these huge antennas were built, and quite a few are still in operation today. But this allowed these 1 square mile facilities with rhombic antennas to be replaced with just a few of these log periodic antennas. So there was no need for 1 square mile for a basic receiving site. And for omnidirectional use, this broadband antenna was developed and patented in 1963. It's called a conical monopole, and it for broadcasts, which are widely used in the military, this allowed them to replace a whole bunch of rhombic antennas with one of these fed with a high power transmitter. And this is what some of the later transmitters looked like in the last 10 years before satellite communication made all of this stuff obsolete. So this is I suppose this transmitter is probably a mere 12 feet wide. 40 kilowatts. And the diversity receivers were still pretty big, but a whole lot smaller than they were in World War II. And this is a dual diversity receiver from 1960. And now we're getting to the point where all this technology is about ready to come to an end. So this is a transmitter from 1970, and 370 or so of these were built. And here is a real progenitor of the end. This was a satellite communication system, but it did not use electronic satellites, it used the moon. And I don't know how many of you in England recognize this name, USS Liberty. This is the naval ship that was attacked in the Mediterranean by Israel during the war. I guess it was in the early 60s when the Suez crisis took place. And you can see the communications terminal right here, 16-foot diameter dish that was used to communicate with Washington, D.C. Via the moon. Of course, an obvious problem is this only works when you can see the moon, so it's good for about 12 hours a day. And that's all, but a lot more communication bandwidth available. So the first satellite communication system occurred before the first satellite was ever launched. And this huge station, NAA, same call sign as the one that was in Virginia, was built for the submarine, the Polaris submarine program in 1961. And the Navy has by now really figured out the message that Marconi learned, the lesson Marconi learned in 1910. And they built this huge site with 2 duplicate antenna systems. So in case one was damaged, you could use the other one, or you could use them together. Each antenna system consisted of a 1,000-foot central tower surrounded by 12 800 to 875-foot towers. And there were 2 of these systems built in Maine. This system is still in use. And the ERP of this system is about 2 megawatts, and it's used for submarine communication. So this was the state of the art of development of the system in the NSS system in Annapolis, Maryland. This is the same photograph that was in the lead-in slide. But it didn't continue in use for very many years because the system in Maine with these 2 huge antennas was so reliable that this small system, a mere 3,000 feet in diameter and 3,000 feet long, wasn't as capable and wasn't as reliable as the system in Maine. So this huge antenna system and transmitters and so on didn't last for very long. This is a receiving site that was built for NSS HF communication. It was built in the mountains of West Virginia. People in West Virginia often refer to this Navy base as the West Virginia Navy. That wouldn't mean very much to you, but West Virginia is about 400 miles from the ocean. So it seemed rather odd to have the U.S. Navy in West Virginia, but there they were, and this was the antenna system that they built. 2 450-foot diameter, fully steerable receiving antennas. Well, this was the real signal of the end of HF radio for the main backbone of military communications. This is the Marisat satellite, and 600 U.S. Navy ships were equipped with 25 kilohertz bandwidth transmitters and receivers to operate on the UHF channels here. And this communication system came into widespread use in the Navy in 1976, and the HF mission at NSS Annapolis was terminated in the same year. And this was taken in 1999. These are all those wonderful 600-foot towers you saw in the first slide, and they all came down, 1999. Actually, all but 3. 3 of them survived. only as a historical site. They were never used for any operational reason. And those 3 towers are still there, and here they are. So when we put together our NSS operations during Armed Forces Day, we sure would like to be able to use these 600-foot towers, but unfortunately, they are located at just beyond the end of a firing range for the Naval Academy. So we are strictly prohibited from getting in this area for obvious reasons. You would not want to be at the end of a firing range just because there's a possibility of putting some ham radio equipment on the air. So we've never been able to use these towers and never will be able to use them. This is what our ham radio field day style of NSS operation looked like. We had 2 50-foot masts, and there's one of them here on the right-hand side with simple dipole antennas. This is our radio station, 2 tents, and a simple HF transceiver here. This operator is on 20 meters, and this operator is on 17 meters, I believe, or perhaps 30 meters. And this is a look inside that station. A Navy Vice Admiral, who's the Director of Naval Intelligence, visited us that particular weekend. And the site where we operate from, these are the original 4 towers from 1918. This is a very old photograph. And we operated in a tent on this location about 300 yards from the original NSS transmitter. All of these facilities are gone. They were demolished many years ago. And then we made 419 CW contacts and 482 single sideband contacts. We thought we'd done real well, but this group of Naval Academy midshipmen, one of whom is a very well-known Potomac Valley Radio Club member, K0DQ, they got on the air in 1965 when all of these fellows were midshipmen. And how did they do? Well, they did well enough to get this letter from the Chief of Naval Operations congratulating them for making almost 3,000 contacts.
Wow.
Compared to our 900 a few years ago. And I think this is the last slide. So this shows our team that operated during the 100th anniversary year of NSS. Oh, and there's one last slide. This is a gentleman who's interviewing for a job at NSS. And if anybody's ever listened to these military stations that were on HF, they typically kept their HF frequencies active around the clock, mostly sending Vs. So this really is the last slide. Okay, David, so back over to you.
Wow, Frank, what a story. I mean, I guess I knew a lot of the little bits and pieces, but to see it all together in one big story, I couldn't help thinking as well when you showed those pictures of your field day there, whatever would those people have imagined, you know, the Marconis and back in the day of seeing a transceiver that small that was on the 7300 or whatever it was. You know, what would they have? They just couldn't have imagined that, could they, in something that small?
That's right.
Amazing. Well, hopefully some of the everybody watching now, I think we've had a few comments, and I'll read those to you in a moment. But I think probably everybody like me has just been awestruck in looking at this incredible story. But if you have got any questions for Frank, who's obviously researched this subject a lot, then this is the time to ask them now, either on BATC or on Facebook. Just type those questions in. If you can put your name and call sign if you have one as well, that would be good. So let's have a look at some of the comments. We had a comment, the first one I sort of saw was from Donard, M0KRK. He says, I've stood on Signal Hill in St John's, temperature -10 and gale force 8. I reckon that what Marconi heard was the chattering of his teeth, he says.
I think that might be correct.
But it was, and I must just get another comment, because he did add to that. Marconi's mother was a member of the Jameson whiskey family, so very suitable for St Patrick's Day.
Very suitable.
Yeah.
And that's one of the reasons he was able to acquire so much land. out on the far west coast of Ireland.
Really? What, because of the family wealth and with the
Yes,
whiskey?
yes.
Yeah, okay. Dave GAADM says 10 kilowatt spark gap transmitter, crazy. I quite agree. That's incredible. Dave G0KHC says, I think I'll stick to SDR, but I think the technology's got a bit smaller now. And what else have we got? Other questions, Tammy? Have we got anything here? One of our members, well, you know, because he booked you some time ago, G3LDI, Roger, Chris G0DWV has said that the rhombic antenna array, I think that's when he said it was just like Roger's. So Roger has quite an aerial system there, I think, an antenna system. You've got quite an antenna system yourself, haven't you?
I do, but nothing like 1 square mile. And 1 square mile was that was the standard. You know, if you were going to put up a receiving system anywhere in the world, the first thing you did was look for 1 square mile of land, minimum.
Yeah, that's not, well, nowadays as well. I mean, certainly in Britain, you wouldn't have that. I mean, I was taken by a couple of the comments on there, and I know you had a lot to get through there, but one of the things I noted that you said that the superhet wasn't permitted on the US Navy ships. Is that because of the interference, the oscillations and things that would cause?
Yeah, so let me expand on that a little bit. The competing technology is the tuned radio frequency receiver, and what that technology is, it's very much like SDRs, as a matter of fact. There is no oscillator there is no heterodyning involved, so it's the tuned radio frequency receiver. The entire receiving chain operates at the frequency of the signal being received, so there's no intermediate frequency. So the tuned radio frequency receivers were the only receivers allowed on U.S. Navy ships for quite some time, because they were very worried that the heterodyne oscillators would radiate and then, of course, set up the Navy ships as a target.
Yeah, give away where they are. Yeah.
So it took a bit of development for the radio equipment manufacturers to give the Navy enough confidence that the heterodyne oscillators would not radiate. I remember at my previous QTH, not very far from that NSS transmitter, there was another ham in the same community where I lived who had a regenerative receiver made by Heathkit. And I could always tell when he was listening to me, because I could hear the regeneration from his receiver very close to where I was transmitting.
Yeah.
So this is a very real threat.
So they had a point, probably, didn't they, in those days as well? I just find it incredible to look at the technology and things used there. Lots of people saying thank you very much for a fantastic talk, Martin, and lots of people. I don't want to single anybody out because I'll miss somebody. Robert Bob Clayton, G8STU, says work out the EMF for that L9T, which I guess is a lamp. I mean, just you saw probably at the beginning of the program that we're having some changes to our licenses, and I guess they may happen to you as well with the ICNIRP and the EMF. And we're going to have to suddenly account for it. And I think what he's saying is, imagine having to calculate the EMF coming off those antennas.
Yeah, that's right. That's just well, for example, one of Marconi's transmitters that he built before World War II was near Cape Cod, Massachusetts. And one of the reasons why that facility was decommissioned was because they had a hard time avoiding catching the low bushes and growth near the antenna system. They had a difficult time controlling fires. So, and you definitely could not walk out onto that antenna system when the transmitter was on the air.
No, you're right. That's the threats there. A few other questions. Sunny M0SYW says, has Frank got plans to place an 8,000-foot aerial? He says.
That's a good idea.
You've got a lovely array there. I'm looking on your QRZ page earlier today, writing up, doing a bit of homework on it, and that's quite an array. So if you want to have a look at Frank's antenna array is quite impressive. W3LPL, if you put that into QRZ, you'll have a look at your wonderful array there. Malcolm G3PD8, sorry.
But David, since you brought that up, let me make a very important point, and that is to enjoy HF long-distance communication, it is not necessary to have the kind of huge antennas that I have developed here. You saw the photographs of what we used at NSS Annapolis for our commemorative activities, and those are very simple stations with wire dipoles and ordinary 100-watt transceivers, and we do just fine with those. Yeah. You don't need 200-foot towers and acres of land to have a lot of fun on HF.
I think that, and that's a very good point, Frank, because as you know, and I'm sure it's the same in the US, a lot of newcomers have come into our hobby in these COVID times, and you know, it can be a bit daunting if you look at something like that and think, well, I'm never going to have a station like that, so I'll give up. You're right. I mean, a good old piece of long bit of wire tuned at the right amount can be as effective as some of those big arrays, can't they?
Especially with some of these new digital technologies that are so popular.
Yes, incredible. Malcolm G3PDH says, do you think Marconi heard a harmonic at a higher frequency?
I don't have an opinion on any of that, but the technology he used was very broadband, so it's entirely possible. And in fact, I would say it's likely, but I don't know the answer to that question.
And Roger came back, and Roger G3LDI says there are some interesting YouTubes from Point Reyes Naval Station still transmitting on weekends at 14.050, sorry. Yeah, 14.050 megs.
Yeah, Point Reyes was not a naval station. It was it was run by the Radio Corporation of America for commercial trans-Pacific communications. And yes, that station has been preserved. It's one of the very few of those old stations that's still preserved, and most of the transmitters there are still operational. The radio club that keeps that going is quite remarkable.
Absolutely. One other thing I couldn't help noticing, because nowadays we're all getting very conscious of all of our interference, the QRM that we're getting from the internet particularly, and things like that. But you said in your talk that there were problems in 1918 where they were picking up power line interference in Washington. And I just thought, wow.
Yeah, well, power lines were all over the city, I'm sure, but they moved outside the city, but it took them 20 years to actually move.
But they weren't carrying internet and stuff like that over them to cause quite as much interference as we've got here. Well, I think
power lines can be quite notorious, and of course there weren't any radio receivers before that, so there was no attention given to controlling radio frequency interference before 1918.
No, I guess because there was nobody to interfere with, probably.
That's right. Yeah, that's correct.
Fantastic. I mean it, Frank. It's been a fantastic talk. I was tempted by what you're saying about the encryption technology that they could have imagined that they used when we looked at the relatively crude by today's standards technology for transmitters. So I think I'll be looking up that myself, and I'm sure many other viewers as well will be looking up what encryption, how on earth they encrypted things in those early 1900s.
It is an incredible story, and one of the big technology success stories of World War II. It's worth following up on that.
Going to have a look at that. Well, I hope you'll come back to see us again sometime as well, Frank, because it's been another fantastic talk from you. And
well, thank you for the invitation, and I'm always willing to do that. If you look on the internet, you can see that there are a number of topics that I give presentations about. For any of you who happen to be members of the American Radio Relay League, the May issue of QST, which will be published in 4 weeks, will have an article that I wrote on solar cycle 25. It's the cycle that began 14 months ago, and we all have high hopes for a really good cycle 25, and there's an article to be published in that magazine. And for anyone who doesn't subscribe to it, after the magazine is published, that's about 4 weeks from now, I'll be happy to provide a copy of the article for anyone who'd like to read it. But I'm not allowed by the publisher to make that publicly available until the magazine has been published.
Okay, we've got one other question just crept in here. If I could ask you this, Frank, this is a very good question. What would be your answer to who had the most input to the invention of radio? This is from Les Cropley.
Well, there were so many. If I were to pick someone, it would probably be Maxwell, because his was the original idea that proved that electromagnetic waves existed. So how could all of this invention ever occur without even understanding that such a thing could possibly exist?
I mean, it's Marconi that's widely attributed to it. It's the name that probably most people every day would think about. But as you're right, there's lots of contributors.
There were many. That's right. They all stood on each other's shoulders. And the magic of Marconi's success was that his inspiration was to make all of this a commercial success. And if you think, for example, if we compare this to the internet, the technology of the internet was very well developed by 1970, but it didn't get widely distributed and available to everyday people for 25 years.
Yeah,
and it's a similar story with radio.
It's having that vision, I guess, to know what to do with it.
Yeah, and I'm sure you remember that in the early days of the internet, there was a great deal of concern about the commercialization of the internet.
Yes,
people were very worried that these commercial interests would ruin it.
I think I must admit it's one of the few things I think is a wonder that actually nobody owns the internet. All right, we pay companies to access it, but it's a wonderful that really, largely speaking, greatly speaking, it's kind of for everybody out there. So that's one of the nice things, isn't it?
It's threaded together by standards.
Yes,
that's what makes it work.
Yeah,
interoperability that governed by standards and standards bodies.
Yeah. Well, Frank, I feel another talk coming along there anyway, and we do hope to see you again. But once again for tonight, Frank, W3LPL, thank you ever so much and take care of yourself. See you soon.
Okay, David.
Thank you.
Thank you very much.
Thank you. There we are. What a wonderful talk. Very inspirational. And I'm going to be looking up how they did encryption in those days. That's incredible, really. So anyway, just to remind you, that's almost the end of the programme. But next Monday, the 22nd of March, we've got the Monday Night Net with the subject of childhood TV programmes. And at 8:30, we've got the 80-metre CW Net. And on Wednesday, a week tonight, for NARC Live, it's the ICN NIRP special, all about EMF, with our EMC advisors, Mike and Tony, and also Steve G0KYA, hopefully answering some of your questions. So if you've got any of those questions you want to send us in advance, then it gives us plenty of time to get them, then send them to us to the usual address, radio@dcpmicro.com. As well as that, we love your stories, photos, anything else fun as well. That'll stop me having to do this, maybe. You never know. Just a sharp pair of cutters. Yeah. Actually, I should just tell you, Tammy, actually, I did send a little message because one of our members is a professional hairdresser. You don't know I did this either. And it's Ken, M0KJW. And I did ask him, did he do ladies' hair? And he said no. But this was what he said to me. And now I tell you. My best tip for home hairdressing would be don't. Be patient. We'll soon be able to go again. Get your appointment booked in ASAP. And don't worry about looking a mess. We're all in the same boat. Shirley, his other half, didn't realise that he had curly hair until now. So thanks, Ken. There's your advice. So you're safe.
I'm safe.
For now. All right.
Okay, good.
Ladies and gentlemen, thank you very much for joining us on NARC Live. And we will see you again next week. So from the moment, though, from Tammy M0TC.
Goodbye.
And from me, David G7URP. Take care of yourselves and get on the air to care. Bye-bye.